Artificial intelligence is the buzzword today, AI, as we know it. In these series of YouTube videos, I'll walk you through what is AI, the whole spectrum of it, some terminology, some concepts, and we'll dive deep into some of the details and areas of artificial intelligence. Okay, so it will basically tell you what to look for and what all things to learn when it means or what when we talk about AI. Okay, so in this first AI 101 talk, this is the agenda. We'll first look at the AI spectrum, what it entails, what it covers, and what it is not. Then we'll look at a little bit of terminology within AI. Okay. Some of the concepts that we'll go through will be the machine learning basics, the data science as we know it, the deep learning, transformers, and the reinforcement learning, which is kind of, the new upcoming area within AI. Okay, so let's get started. Okay, so this is the whole spectrum of AI, right? This circle, the outermost circle of AI, artificial intelligence, is basically AI. Okay. Now, as you can see, right, data science kind of overlaps with artificial intelligence, but it's a little bit of orthogonal uh, aspect here, right? It goes a little bit of beyond AI, as you can see, right? This particular area of data science. Okay, so that we're not going to cover in these particular series of videos, but I mean that is some important thing to know. Okay, now all these other circles are kind of embedded within AI, right? Like machine learning is a part of AI, right? Machine learning is a subset of artificial intelligence. Okay, generative AI is further subset of machine learning, right? I mean, generative AI got the popularity recently with all these chat GPTs, Bloomberg GPTs, whole slew of GPTs, the open AI, right, as we know it, right? Um, and then the LLMs or the large language models is actually a subset of generative AI, okay? So there is a little bit more than LLMs when we talk about generative AI, right? I mean, LLMs are typically for text, right, which was kind of the majority that started with ChatGPT, right? But then there is a little bit of imaging, audio, video, right? And then this gap is sort of growing as there are more stuff in generative AI that is happening beyond LLM, right? So there's a little bit of kind of, a background where we are and what we'll talk about in this particular series of videos, right, of artificial intelligence, right? So, I mean, to summarize, I mean, artificial intelligence kind of the biggest circle, right? It overlaps a little bit with data science, right? But data science goes a little bit beyond AI, okay, which we are not going to again talk about in these videos, right? But then the rest of these, like machine learning, generative AI, LLMs, right? They kind of, sort of are the circles within, right, with a smaller scope within AI. Okay. Okay. Uh, so what is AI? Right. AI is basically human-like intelligence as exhibited by machines. Okay. So AI consists of what that machine intelligence is made up of, right? How to use it, how to solve your problems with it, right? And how to make your life easy, right? I mean, the biggest thing that you keep hearing about AI is the automation, right? To make our life easy, right? All the mundane tasks, you leave it to AI so that you can focus on business, you focus on sort of, your things of interest. Okay. So, well, what is the scope of AI, right? McKinsey has predicted that by 2033, right, within like, next uh, 5 to 7 years, right, there will be 13 to 22 trillion value creation by AI, right? So, I mean, this is like, addition to what we have already, right? And out of that 13 to 22, right, 3 to 4 uh, trillion would be by generative AI. Okay, so that is kind of, the sort of, business impact of this, right? And the Another thing to know is it will have a very wide impact across many industries, like, starting from retail, travel, right? But it has a very wide impact. That is sort of, another important thing to know about AI in general. Okay. Now, a little bit of some basic sort of, categorization of AI, right? ANI, right? It is a artificial narrow intelligence. Okay. So this talks about narrow tricks, right? Like, some little bit of problem solving, right? Some automation that we do. So in fact, most of the AI that we see today is ANI. Okay. Uh, of course, there is Gen AI. Right now, some people actually don't call out Gen AI separate from ANI, right? I mean, Gen AI is kind of, part of ANI. Okay. But I'm just kind of, stating it here because that is a significant part of ANI, right? But one important thing to know is Gen AI is a part of ANI. Okay. Now, what is there beyond ANI? There is a AGI, right? This is a artificial general intelligence, right? So now, basically, what it means is do anything that human can do. Okay, so like, for example, reasoning. Now, some of this gap is kind of, bridging with, like, this deep seek that came up, right? But I mean, there is still a long way to go, right? I mean, sometimes when somebody say AGI, right, it means like, can like a machine write a PhD thesis, right? Or some other people describe it as like, can a machine uh, learn driving by, just 20 hours of instructions as like, humans do, right? I mean, that's what that AGI can be sort of, described in detail. Now, there is beyond AGI, there is a and another important thing to know is that, like, AGI is believed to be like a decade away. I mean, we are kind of, bridging the gap from ANI to AGI, but I don't think it will be here for another decade, right? Another 8 to 10 years. Okay. And now beyond those 10 years is a ASI, artificial super intelligence, right? So where actually people have already started envisioning that this AI can be better than a human. Okay, now that's a little scary, but uh, we'll see. I mean, as I said, right, AGI is also still not here, right, for another decade or so, right? Now, ASI, we don't know. I mean, it's kind of, not, may not even be next a decade beyond the next decade. It could be like, a century beyond the next decade for it to be there, right? I mean, it's that kind of a scale when you talk about sort of, how long it will take for us to achieve some of these. ANI is already here, right? Gen AI being a significant part of it, right? AGI, maybe a next decade, right? ASI, maybe a century beyond the next decade. Okay, so that is kind of, sort of a picture of AI as we can have it. Okay, uh, or you can probably call that is the spectrum of AI, right? As we can have it. Okay. So now a little bit of terminology, right? Machine learning. So what is machine learning, right? So computers learn without being programmed explicitly, right? So basically, you just feed data to these machine learning algorithms, right? From the data, it sort of, derives intelligence, right? Now, once it has derived intelligence, right, as sometimes it's called as a trained model, right? Now, to this trained model, you actually give a problem, right, or you give a data that was not in the training set, right? So it hasn't seen that sort of, question before, but it can still answer it, right? I mean, that's kind of, the learning without being explicitly programmed, right? So I mean, for, 10 sort of, inputs, you have given 10 outputs, right? But now you provided the 11th input, and it can generalize based on the first 10 inputs and sort of, give a reasonably good answer or reasonably accurate answer for that 11th problem that it hasn't seen before, but it will be able to sort of, deduce or extrapolate from what it has already learned. Okay. The next one is data science, right? So what is data science? So it's basically extracting knowledge and insights from data, right? So now, as you can see, right, I mean, it's kind of, little beyond AI, right? Because it could be even kind of, a little bit of automation, right? I mean, some organization of data, data transformation, right? Some data engineering also can be part of this, right? Uh, like a databases as we traditionally know, right? Part of it, or big data as we know, right? Could also be part of it, right? Because it's basically dealing with a lot of data, right? And extracting knowledge and insights from it. Okay, so that's why it's a little bit of orthogonal to AI. Okay, now deep learning, right? Deep learning is basically whatever you can do with neural networks. That is deep learning, right? I mean, that is a thumb rule. Okay, so just as our brain gives us intelligence, right? Neural networks are believed to give intelligence to the computers and thus AI, right? I mean, that sort of, stems into AI, right? I mean, just like human intelligence comes from brain, right? AI or artificial intelligence, machine intelligence comes from neural networks, right? I mean, that's kind of a parallel here. Okay. Now, a specific type of neural networks are called as transformers. Okay, and that is the T in like Bloomberg GPT or Chat GPT, right? I mean that GPT, right? That T is the transformers, right? So all that generative AI is based on a specific type of neural networks which are called transformers, right? So we'll spend some time on that also in this particular series, in this particular video, right? And the last but not the least is the reinforcement learning, right? I mean, you must have heard the recent buzz of DeepSeek, or specifically DeepSeek R1, right? So it was trained on reinforcement learning, right? So I mean, basically, kind of key here was that it's a pretty good model, right? People like the results it gives, right? And still, it did not take as much money to train it, right? Because it was trained using reinforcement learning. So that is kind of like a practical aspect of deep learning when it comes to sort of AI, okay, or a generative AI when it comes to DeepSeek R1 model. Okay. Okay. So we'll start with machine learning, right? So what is the difference in machine learning from a traditional programming, right? So in traditional programming, you basically have a function, right? So you already know sort of, how to compute output from a given input, right? So you basically give an input to this function that you have written, right? And that generates the output for you, right? So that function kind of, already covers all the types of inputs that it can have, right? So it kind of explicitly programmed, right? And of course, if it has an input which it cannot handle, I mean, probably it will throw an error, right? Or it will sort of, will have uh, undefined behavior, so to say, right? So like, for example, a function which operates only on integers, right? You give it a float, right? It will error out or it will crash or whatever, right? Uh, so that is a traditional programming. As opposed to traditional programming, in machine learning, basically you have a input again, right? Same as traditional programming, right? Or it's in the machine learning world called as data, right? Or data set. Okay. Now it may or may not have output, right? And that is called as labels, right? Uh, Now we'll also touch a little bit upon on this, but when you have the labels, right, in machine learning, it's called as supervised learning. When you don't have labels, it's called as unsupervised learning, right, where it's kind of trying to find uh, insight uh, given the data. Okay, and what is the output that you get from this machine learning model is kind of a function, right? I mean, it's kind of transformation of the traditional programming where you kind of have written a function, right? But here in machine learning, you basically have a model, right? You train it over given input, optionally output in case of supervised learning, right? And out comes the insight or the intelligence, right? Or a trained model, right? And which is like a function in the traditional programming, right? So this is kind of, a whole paradigm shift in machine learning, right? Where like, it's not explicitly programmed, right? It's kind of derives intelligence out of the data that you have fed into it, right? Along with optional labels or outputs. Okay. Okay. Uh, so diving a little bit deep into machine learning, right? So basically what you have again is you sort of, have a data, right, that you input to your method, right? Machine learning methods could be a, a model, right, of like a regression, classification, clustering, right, recommender, right? Now that would be sort of, a task that you would perform, right? Now that model has parameters, right? It has some optimization algorithm like, gradient descent and all that, right? And then out comes the intelligence, right? That you evaluate how good that intelligence is, right? With some sort of, criteria like accuracy or F1 score, right? Or whatever. So again, we are not going to cover all that here, right? But this is kind of, the idea of the whole machine learning pipeline, right? Where it's sort of, starts with data, right? Fits into the ML method, right? Which will kind of, perform this task of regression, classification, clustering, depending on the method, right? It will sort of, train the model, right? Update the parameters using some optimization algorithm like gradient descent, and out comes the intelligence that you evaluate, and you actually even improve sort of, this whole cycle, right? It's kind of a cycle that will happen in this machine learning pipeline. Okay. Uh, so what are the types of problems and solutions in the machine learning? So there is a regression, right? So in regression, you have a real valued output, right? So for example, predicting house prices, right? So based on the data that you have for a neighborhood for the past month, you predict what will be the sale price when you put your house for sale, or when you want to go and buy a house, you want to know the budget, right? So you could use these regression models there, right? Second is classification, right? A typical is a product reviews or a restaurant review, right? Like, that you see on Zomato, right? Or product review that you see on Amazon, right? So it's like a 1, 2, 3, 1 to 5 stars, right? So that is a classification. You classify that into categories, right? The next one is a clustering, right? So this now gets into the unsupervised domain, right? So regression classification both are sort of, supervised learning where the data is labeled, right? You know the outcome, right? You already have data, or you already know the sale price of the houses that were sold in the past, right? Or you already know the rating of the products that were already reviewed by customers, right? Uh, in case of unsupervised learning, you don't have that, right? So, for example, it could be a document retrieval, right? Where you don't know upfront what is the category of a document, right? You are given a whole slew of documents, and you want to sort of, find out whether it's a technology, whether it's uh, finance related document, right? That is one example of clustering, right? Recommender systems, right? Like a product recommendation, right? For example, you see it again already, right? In Netflix, right? It recommends movies, right? Or YouTube recommends videos for you to watch, right? So, or even Amazon recommends products to buy, right? So all these are recommender systems, right? Deep learning neural networks, right? So we'll cover that a little bit separately as one of the topics, right? Time series is one problem, right? Forecasting, right? Like a stock price, right? What will be the price of a stock? When I should buy, when I should sell, right? This is whole different sort of, type of problems which are called as time series, right? NLP, NLU, right? This GPT-3 chat GPT, right? Again, we'll cover that little separately in this series of videos, right? Image recognition, that was traditionally called as computer vision, right? And acoustics, right? Which is related to sound. Data science, okay? So this is a whole life cycle of data science, right? So first of all, you sort of, develop some business understanding, right? Then you kind of do some sort of a data mining, as it was called before, right? So you gather and scrape the data necessary for your project, right? So let's say if your project is in the finance domain, right, then you'll kind of go through finance related information, right? Like maybe like business reports that were filed by companies, right? Or maybe information about banks or financial institutes, right? Depending on your problem, right? The third step is you need to clean that data, right? I mean, all this data that you got, right, may have a bias, may have a skew, right? You want to prevent that, right? So you'll do that with data cleaning, right? Then you'll do some data exploration, right? So you'll kind of make some hypothesis about your defined problem, and you'll kind of visually analyze that, doing some sort of visualization tools and all that, right? uh, then you do some feature engineering, right? So you basically, I mean, some of these features might already exist in data, like maybe age, gender, it could already be there as columns in your tables, right? But some of these features that you want to use for your machine learning models might have to be engineered. Okay, some of them could be simple engineering, like maybe some sort of a formula, right? Or some could be little complex equations. Okay, then you do some sort of predictive modeling, right? Based on feature that you engineer, you kind of train your model, right? And you kind of sort of predict what would happen for something that you haven't seen in the past, like for example, predict the price of a stock tomorrow, right? Or next month or next year, right? That is some sort of a predictive modeling, right? And then you do some data visualization. Okay, uh, so what is the sort of broad uh, premise for data science? So it's analyze large data to extract and communicate actionable insights for business, right? I mean, that's what data science is all about. Okay, so first of all, it's talking about a big data, right? Now it's talking about extracting intelligence, right? Insights, and uh, sort of the next thing is you communicate, right? Right, so some people also say that a data scientist has to be a good storyteller, right? I mean, whatever you extracted, right, you need to tell to the business people, right, to which they can relate or they can see value of what you are saying or what you have found. And the last but not the least, it should be actionable, right? I mean, you sort of said that, oh, like your data has this, right? But then what do you do with it, right? Maybe you change this or change that, or this is what you are doing, continue doing this, right? I mean, that whatever insight you gave, provided, should be actionable, right? So that business can sort of not falter, or it kind of improve, or whatever, right? Grow. Okay. So what are the skills required for data science, right? I mean, it's kind of combination of all five, right? Like a statistics, machine learning, little bit of coding, right? That you need to do, communication, and logical thinking. Okay, so that's the whole gamut of data science. Okay, deep learning. Okay, uh, so as I said, right? I mean, deep learning is primarily driven by neural networks, right? Uh, all the models and all that we talked about, right? They have some sort of input on the left hand side, right? And then they have some structure, right? So in case of neural networks, basically it has an input layer, it has a hidden layers, right? And it has an output layer. Okay, and they are connected all throughout. Okay, now basically what is the important thing in neural network, right? So these hidden layers, basically they have some sort of a function, right? So whatever inputs that it got, right, it operates on that input, it applies some sort of a transformation on this. So this transformation actually makes it sort of non-trivial. Okay, uh, and sort of feeds it to the next layer, right? So on and so forth until it comes out. Okay, now all these edges are having some sort of a weights, right? Or sometimes they are called as model parameters. Okay, so you might have heard about these parameters, right? So they are kind of important in any model, right? And in neural network, these are basically nothing but weights on these edges, right? So what happens, I mean, you have some input x1 that is coming in, right? So when it's fed into this first uh, sort of neuron on top in the first hidden layer, right? It's multiplied by this W11 superscript 1. Okay, when it is fed to this second neuron in the first hidden layer, it's multiplied by W12 superscript 1, so on and so forth, right? So I mean, you can see, I mean, these parameters, like, and that's what they go into millions and billions, right? I mean, you'll see the models, right? Chat GPT probably has, like, whatever, 18, 25 billion parameters, right? Basically, these are those ages of the neural networks, right? I mean, all, as I said, all this generative AI is transformers, right? Transformer is a subset of neural networks, right? So when transformer look like this, basically, okay, and all the parameters and all that they talk about are nothing but the weights on these edges in the neural net. Okay, so again, what you do here, right? So you basically have a function, right? So basically the neural net sort of, they discover the function of x1 to xm, right? This sort of, the uh, complete set of input that is given to it, and it transforms it into y1 to yp, right? So I mean, as we already saw, that machine learning paradigm shift, right? So where you have an input, right? You have an output optionally, again, right? In case of supervised, unsupervised may not have output, right? Typically in neural network, you will have output, right? It's kind of a labeled data, okay? And what the neural network do is they basically discover that function f, that transforms x1 through xm to y1 through yp. Okay, how does it do it? It basically assigns some weights to the edges, right, with some training algorithms, like gradient descent, which will do a forward propagation, so it goes from left to right. It does some backward propagation, right? It comes from sort of right to left, uh, and then it updates these weights, or updates these parameters, updates these weights on edges or parameters, right? And it does iterations of these. Iterations are called as epochs, right? So it will kind of give some weights, right? And again, there are techniques. It's not very random, right? There are some techniques which even assign the initial weights to these edges, right? So it will start with this input, some values to these parameters, do some forward propagation, backward propagation, and iterate, right? Do the epochs, and the epochs will be typically hundreds, thousands, if not, tens of thousands, right? And then it will converge, right? So it will find the ideal weights for your particular problem. Now, once you sort of fix these weights, you freeze the model, right? Now you give it any input, right, which it hasn't seen in the past, right? It will give you fairly accurate output, right, based on the training it did on the input data that you had. Now, some interesting types of neural networks: CNN, convolutional neural network; RNN, recurrent neural network. Convolutional neural network is typically for images. RNN is for audio, right? CapsNet is an interesting type of neural net, and transformers, right? Again, which is what we are converging to with this generative AI and the GPTs. Okay. So you'll see a little bit of detailed description on deep learning in one of my Medium blogs, to which I have given a link here. Okay, it's a primer on neural network. Okay. Uh, Now that brings us to the interesting topic of transformers, which are like a specialized neural nets, right, which drive all this generative AI, the GPTs, the Bloomberg GPT, Chat GPT that we DeepSeek R1 that we talk about today. Okay. Uh, so in 2017, right, there was a famous paper which was called as "Attention is All You Need." Okay. So an interesting part or innovation of the transformer is it has something called as a attention layer. Okay. So it's based on encoders and decoders, right? That is one sort of fundamental concept of transformers, right? It has combination of attention and fully connected, or FFN layers, right? That's what you kind of put together in here, right? Now this attention layer is of three different types, right? So first is a self attention, right? You sort of pay attention to yourself. Right. The second thing is multi-head, right? So you kind of have a multi-head attention, right? And you have the third type of attention, which is called as a cross attention. Okay. So in the self attention, basically it has a query, keys and values derived from the same input, right? So it basically has a query. Right now it says what are the important aspects of these queries, which are the keys, and what are the values of those keys, right? In multi-head, projects queries, keys, and values h times on multi-dimensional matrices, right? So self is on the same input, right? But in multi-head, you have a multi-dimensional matrices on which sort of, it projects these queries, keys, and values, right? And it does it h times, right? In the cross, as the name suggests, it's over two input sequences, right? Not just on the same input. Okay, so that is a brief on transformers which drive the generative AI. Okay, uh, then the last but not the least is the reinforcement learning. Okay, so as we have been talking, machine learning has three paradigms, right? The first one was supervised, then came the unsupervised, right? Now the most recent one has been this reinforcement learning, right? So this is kind of the third paradigm of machine learning. Okay, now what is the theory behind reinforcement learning? So it's basically based on Markov decision process, right? So if some of you have done a theory, right, or some of your operation research guys, right, you'll kind of know. Okay, so it's not like new, but it's kind of, making that Markov decision process little practical, right? Or it's kind of scaling it for the sort of, real life problems, right? uh, and it's also called as dynamic programming, right? Some of you might have learned dynamic programming in operation research, right? So it's kind of, taking this Markov decision process theory into the real world problems with this dynamic programming. Okay, so another important aspect in the reinforcement learning is makes use of samples and function approximation, right, to deal with the scale, right? So you have like, millions of or billions of inputs, right? And you may not be able to kind of, scale, right? So it makes use of samples, right? So it samples the data. Again, there is a lot of theory behind it, how you do the sampling, right? Some techniques there. We are not going into all the details, right? And secondly is whatever functions that you have, right, you do some approximation, right? Again, this is to scale, right, and do some sort of, real time programming so that you kind of, converge sooner, right? If you want to sort of, make some inference, it has to be real time, right? I mean, if you are thrown an image and you want to tell what it is, it cannot take hours, right? It should be sort of, answered in seconds, right? So some of these function approximations are done for that real-time processing, right? Uh, so one important aspect here is there is a exploration versus exploitation trade-off, right? So now what it is? So exploitation refers to applying what you already know, right? If you have already learned something, you make use of it. That is exploitation. Right now, if you know that, oh, like, what I know is limited, right, then you explore, right? That is what called as exploration. Okay, so kind of, reinforcement learning kind of makes that trade-off. Obviously, I mean, if you want to explore, it will be slow, right? But it will be better, right? Exploitation will be fast, but it will be limited based on what you already know. Okay, so kind of, this is a diagram depicting what reinforcement learning is all about, right? So basically, there is an agent, right, that is kind of, working in an environment, right? So I mean, in that environment, you basically agent is observing the environment, right? And it basically gets a reward, right, and it gets a state. Okay, and what agent does, it takes an action, right? So it takes an action, right? That action is on the environment, right? So because of that action, the state changes, right? And the environment also tells the reward, right? So basically, what reinforcement learning is all about is that this agent learns based on the reward, right? So, like, if the action that agent takes is a good action, right, it will be rewarded. If it is a bad action, it will be punished, right? And agent learns, right, based on the reward. It will keep doing those actions more, right? If it is punished, doing it will stop doing those actions, or it will, like, reverse that action, right? So if it did something which kind of gives a punishment, right, it will try to do something opposite, right? I mean, you did something bad, then you will try to do something good so that you get rewarded. I mean, that's the whole idea of reinforcement learning, right? So again, I mean, sometimes it may look like a trial and error, right? I mean, you're taking a trial by taking an action, right? Okay, you made a mistake. Oops, sorry, I'll do something different, right? I mean, but that is the intuition behind it, right? I mean, there is a lot of theory, right? But then this is sort of an intuition, right? Now, this is what makes it practical, right? All this theory behind it, right, makes it sort of scale, able to solve the real world problems, right? Now, uh, what are the algorithms here, right? So this is sort of a control learning that this agent is doing in the environment, right? So there are sophisticated algorithms. I'll just name a few. So there is a Monte Carlo, there is a TD learning, there is a Q learning, SARSA, DQN. Okay, I mean, again, I'm not going to go into all the details, right? But then what I'm trying to say is that I mean, this trial and error, as sort of I depicted and sort of described, has a lot of theory behind it, like this Markov decision processing, dynamic programming, right? It kind of scales with this samples, function approximations, right? It has a little bit of exploration versus exploitation trade-off, and there are sort of well defined and well tested, tried and popular control learning algorithms that are evolving, right? And then this sort of being a new field, more and more algorithms are coming up. Okay, so that is something you should know, learn, right, and develop, evolve. Okay. uh, Now, this reinforcement learning, as it evolves, right, again, is going to get classified into these different types of reinforcement learnings, right? So there is associative, there's a deep reinforcement learning, there is adversarial deep, right? There is a fuzzy, there is an inverse, and there is a multi-objective, right? So I mean, uh, this is more complex, where the objectives could be multiple, right? I mean, you don't want to just sort of make more money, but you want to make more money but be happy, right? Or you want to make more money and you want to be more happy, right? And so on and so forth. So you can sort of keep adding different objectives, multiple objectives to your problem. Okay, so with that, we come to the end of this AI 101. So please provide me ideas if you have any for these talks, right? If you like this video, click the like button, subscribe to my channel, and look forward to more videos in this series. And good luck exploring AI, artificial intelligence. Bye.